Hey guys, Mr. Race here. I'm going to help you guys out on activity 118 today. So today's the first day. We're just going to do part one today. So if you guys want to go ahead and open it up, part one is a quiz, but there's going to be lots of parts to it that we'll make sure we go through and understand. So it's a fairly long quiz, but there's only 2 questions that's going to be graded. So our goals with this one here is make sure you guys can use if statements to create conditional execution and create an algorithm with nested conditionals and nested iteration to stop the turtle movement when they collide. All right, so let's first talk what a conditional is. Okay, there's a lot of situations where you only want to execute a certain statement if certain conditions are true. This type of situation is called a conditional. Conditionals occur in everyday life too. So as you make decisions. So for example, think of how you got ready this morning. Maybe you checked the weather outside to see if it was cold or rainy, then you grab a jacket or a heavy shirt. And if you had plans after school, did you grab something extra in your backpack? And if the school's menu wasn't what you like, did you pack your own lunch? And if your favorite food wasn't in the fridge, did you grab something else? So a lot of these decisions could be made in a short time between waking up and leaving the house, but they are all conditionals. All right. In Python, we use the if statement. All right. So the conditional statement is called if. The block statements indented under the statement will only execute if the condition is true. Otherwise, if it isn't true, all the code in that block will be skipped and not executed. In this way, the condition runs parts of the programs through selection. So let's observe this syntax here. So the if keyword, we have the if that starts the code, and you'll see it's a lot of different colors. We always put a comma after the conditional. The conditional is the statement that we'll put in between, and then the block statement goes underneath it. So let's look at in action here. So we have a line of code here says number equals integer input enter number. So we're going to get a number from the user and turn it into the integer. And here we go, the if conditional. We have if, here's the condition, and then we end with the colon. So if number greater than equal 90. So if the number is greater than or equal to 90, we'll print input is 90 or more. So if I run this and I type in a number and I type in 300, press enter, input is 90 or more. Now, if I type in a number that's less than 90, like 5, and press enter, nothing happens because this line of code gets skipped, and that's the end of the code. All right, so we ran the program experiment by entering different inputs and see how it responded. The code will do nothing unless the input was greater than 90. This behavior can be confusing to a user, making them think that nothing is happening. And it probably would be confusing if nothing did. So luckily, the if statement can be expanded to include an else clause. The else clause handles the situation when the condition is not true. If the condition is true, the program will execute the block of statements directly below the if statement. Otherwise, or the else will execute the block of statements below its else clause. The else clause serves and catches all when the no other condition is met. So we can look at that in an example here. So we have our if condition. So if it's true, we run that. Else, we can add an else clause that lines up with that if. Ooh, kind of hard to see. I'll do that again. It lines up with that if. And runs the block code. We can see my 9 club suggestions. All right, so we can take this code and add an else clause, and this else clause has to line up with the if. So they're on the same tab notation here. So if the number is greater than 90, so we'll put in another one like 888, that works. But if I put 88, I get the other input of less than 90. A lot of you guys have seen coding like this before, so it's nothing brand new. Okay, so let's talk about nested conditionals. Nesting is whenever we take a group of functions, or nesting functions when we take a group of functions and put them together. If we nest conditionals, that's just if statements put together. So there are instances where you'd want to test more than one condition at a time. To do this, we'll use what's called the nested if or else statement. These statement types is an if and else statement you use inside an if and else statement. This is useful when you want to test for more than one condition at a time. For example, like one range of a value. So we're going to analyze the code here and look to see. So we have an if statement. So if number is greater than 90, we'll input 90. And then we have an else here. After this else, we're going to check if and it's greater than 80 and tell them that this. Else, we can line up an else. So we have several nested conditions here. And based on the number we type in, if I type in 100, that's bigger than 90. But if I type the number let's see, 65, I get input is 60 or more because it went through, it failed this first condition. So it went to the else had to check another thing. It failed that. So it went to the next else, but the next else checked to see if it was bigger than 80. It failed that. It went to the next else. It checked to see if it's bigger than 60. It is. So it ran this line of code and it skipped the else there. All right. As with most programming, you can accomplish goals in many ways. So there's another way, perhaps more straightforward way to accomplish the same goals as the previous program. And this is called the elif statement, or else if. All right. And it's just a combination of else if. So the elif condition here is sandwiched in between the if and the else. And we use the statement elif followed by the condition there. This will line up a block and code so they don't become so diagonal. So if we have multiple things that we need to check, like the range of values, we can use elif to keep everything more organized. So if we look at the code here, this code does the same thing that we did before, except for now, if you look at it, the complexity of it is a lot more simpler. Everything's lined up. So the same thing happens if I run this. There we go. Type in the number 65. I still get the same output. It did the same line of code, but it went through. All right, so we could revise the print statements in the code editor to enter grades or more. And so if we wanted to display letter grades, A, B, C, D, or F, and we could do that too. Yeah, I think you guys could know what to do, right? Just change that to A. I don't think we need to do that, but let's look at this one here. All right, I have integer equals input enter number, and we're going to check grades here. So I have if number is greater than or equal to 60, print D, elif number greater than 70, print C, elif number greater than 80, print B, elif number greater than 90, print A. All right, sometimes an if statement can produce unexpected results. Within an if and elif structure, once one condition is matched, the rest will be ignored. So predict what will happen in this new revise. So if we run this here, what do you think will happen? Like if I pick a grade, like I got an 83 on a test, I know an 83 is a B, and I enter this, I get D. Okay. Why did this occur? So, well, this occurred first because it checked to see if the number was greater than 60, which it is. It ran the statement there and skipped everything else. So the elif structure is happened now. If we look at this reverse variation, it can mess things up. Now, if we switch this around and started with 90 and check to see incrementally below that, it would have got the right answer. All right, next thing we're going to do is look at a nested loop iteration. So nesting loops now, loops inside of loops. So just like with the nest if, else, and while statements, you can also nest for loop statements inside other statements. This is simple but powerful construct in computer science. A for loop will execute a statement, a set of statements, once for each item in the list. So for example, we have the following pseudocode here, the construct for J in the outer loop. So for I in some list, here we have for J in some list, do something. So I have for every day in the week, I have them listed out and have my courses, English, math, computer science. Now this says for every D in days week, print D. And then for every C in my course, print space plus C. So what this is first going to do, or maybe let's look at this and run it and see what happens. All right, so we get Monday, English, math, CS, Tuesday, English, math, CS, Wednesday, English, math, CS, Thursday, English, math, CS, Friday, English, math, CS. So what ends up happening here is first we print off for every D in days week. So we take Monday, that's the first one in the days of week. We assign that to D. We print that off, so we print off Monday. And then we go for every C in my course. So that means for every C in my course. So English, we'll print off space English. Then we'll go through and print off space math. And then we'll print space CS before we start the loop all over again, the large loop here, to move on to the next day of the week. All right, so we can look at this again as a video to describe what's going on here. So we have the days of the week. We start off, first one is Monday. And then after that print command, we then loop inside of it, the inner loop, the math, computer science, and English. Then we move back up. start that loop over again, but with the next day of the week. And this will continue looping on until we get all days of the week. All right. So the question for you guys is, how many total iterations occurred from both inner and outer loops? So we look back to this, how many total iterations occurred? Well, we have one for Monday, and then we have 3 following that. And then we had another one for Tuesday, and then 3 following that. So do the math there, check your total, take a guess, and then turn that in. All right. All right, guys, well, that should be it. If you guys have any questions with this, let me know. But we're just making sure we understand this before we really start jumping into it, executing it in part 2. All right, guys, have a great day.